Hello. Today we're going to wrap up Chapter 16 by talking about something called the Binomial Theorem. This really doesn't have anything to do with probability like our other sections of Chapter 16 did. This is kind of its own little topic, and they decided to throw it into Chapter 16, I guess. But the Binomial Theorem is, binomial means if you have an expression that has two terms in it and it's separated by a plus or minus. So a plus b is called a binomial. And what we're going to do with this binomial is we're going to raise the binomial to a particular power. And I'm going to show you what happens when you raise a binomial to all of these different powers. And up here there's a little introduction that tells you what the binomial theorem really is all about. But in essence, it can be you can follow a pretty good pattern or pretty interesting pattern. And watch this pattern. If you raise anything to the 0 power, you get 1. If you raise anything, even a binomial, to the first power, you come up with itself. So a plus b to the first is just a plus b. And I highlighted these coefficients. The a and the b have invisible coefficients of 1, and we'll get to why I put these in there in a minute. If you square a plus b, that's really a plus b times a plus b, which is a FOIL, F-O-I-L. And after you get done foiling this and combining like terms, you'll get a squared plus 2 times ab plus 1 times b squared. That is after the FOIL. I've just skipped a couple steps, and I've highlighted the coefficients 1, 2, and 1 for a reason. If you wanted to take a plus b and cube it, you'd have to FOIL a plus b and a plus b, and you would get this, but then you'd have to also multiply that by a plus b, which gets very tedious, and it's a long process to multiply a binomial by itself 3 times. But if you did take the time and do that, you would get a cubed plus 3a squared b to the first plus 3ab squared plus b cubed. It's kind of a lengthy process. I'm going to take a plus b and raise it to the 4th power, which is a plus b times a plus b times a plus b times a plus b. And you can imagine how tedious that would get. You'd FOIL, and then you'd FOIL, and then you'd have to multiply that by itself, and you get a really, these polynomials get longer and longer, but you would result with this, the result would be this polynomial, and if you raised a plus b to the 5th, a plus b, FOILed with a plus b, and another multiplication, and another multiplication, and another multiplication, you would get this polynomial. And the reason why I've highlighted all of these coefficients is because they follow a particular pattern. And what the pattern is first I'm going to start with this coefficient of 1, and I'd like you to write the 1 down here. And then these coefficients are also 1. And what we formed is a little triangle of 1s. And now we're going to write this coefficient off to the left, and then this coefficient off to the right, and the 2 goes in the middle, and what we've just done is added 1 plus 1 and gotten 2. And then we can write the next row. This is a row, this is a row, this is a row. Our next row down, if we add 1 plus 2, we'll get 3. 2 plus 1 is equal to 3, and then we have a 1 on both ends. So this 1, 3, 3, 1 matches up with this 1, 3, 3, 1, not by coincidence. Now we're going to go to the next row, 1, 4, 6, 4, 1. And so we're going to mark the 1 and the 1 off to the side. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then the 1s go off to the side. The next row down, we're going to start and end with a 1, we always do, and then we can add 1 plus 4, which equals 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Okay, what we've just created is something known as Pascal's Triangle. This is named after some French mathematician and physicist named Blaise Pascal. And If you wanted to raise a binomial to any power, let's say we wanted to raise it to the 8th power, what we could do is we could keep building and building and building Pascal's triangle by just adding one. Well, we'd have to add ones to the end. 1 plus 5 is 6, 5 and 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, and 5 plus 1 is 6. So we've got this row. This is the second row. This one is the first row, and this top number is called row 0. So we really don't even count that row really when we're talking about Pascal's triangle. So this one is the third row with the 3's in it. The one with the 4's in it is the fourth row, and I hope you get the pattern. This is row 5, and this one is row 6 because of the 6's. So the row number happens to be these numbers right here. And if you wanted to raise a binomial to a power, what you can do is you can build Pascal's triangle. Whatever power this is, you're going to go down to that particular row of Pascal's triangle, and you're going to get the coefficients. And then I'll show you how to build the other parts of each term in here. What I want you to notice, though, is this particular formula right here. This is very yucky. This formula is on the reference sheet. I don't think I've ever had any students use this. If you'd like to figure out how to use this, these are NCR numbers, you certainly are welcome to, but like I said, I don't think I've ever had students refer to this on their reference sheet because what I'm going to show you, this little trick, is going to be more helpful than this formula is. Okay, so this is how we expand m plus 2, which is a binomial, to the third power. This 3 means we're going to go to the third row of Pascal's triangle above. And when we go to the third row, we go to this row called 1, 3, 3, 1, and we're going to write it in a column. So this column is written like this, 1, 3, 3, 1. Right? So this is the third row. If this was m plus 2 to the 6th power, we'd go to the 6th row and we would write 1, 6, 15, 20, 15, 6, 1, and we would write all those down. The next thing we're going to do is we're going to take the first term and we're going to write it beside each one of those Pascal's triangles numbers. So m is the first term and we're going to write it next. Now this means multiplication. So this m gets raised to the power of 3. Because of this 3, we start with a 3, and then it goes down to a 2 and a 1 and a 0. Then the next thing we're going to do is we're going to put a 2. Here's the second term of the binomial. So this 2 goes next to each one of these m's. This looks funny at first, but after you get the pattern, it's pretty fun. So what we're going to do to this 2 is we're going to raise it to the 0, to the first, to the second, and to the third power. And then what we do, so we've got the Pascal's triangle row, we have the first term raised to those powers, we have the second term raised to the powers, and what we're going to do is we're going to add all of these terms together, and we're going to simplify them. So from here, we're going to just draw a little arrow and we're going to simplify them. This is 1 times m cubed, which is m cubed, times 2 to the 0, which is 1. So 1 times m cubed times 1 is just m cubed. Now what we're going to do is we're going to multiply. Now it's important to know that you're multiplying 3 times m squared times 2 to the first. 3 times 2 to the first is 6, and m squared is next to that. So remember, these are all multiplied within each term. The next thing we're going to do is simplify this next term. 3 times m to the first times 2 squared. 2 squared is 4. 4 times 3 is 12. And m gets raised to the first power, and I'm not going to put the 1 there. And the last term will be 1 times m to the 0. Well, m to the 0 is also 1, so 1 times 1 times 2 cubed, which is 8. and these are all added together, so our final answer is each one of these four terms, m cubed plus 6m to the second plus 12m to the first plus 8 would be our answer to this problem if we didn't want to say m plus 2 times m plus 2, which is a FOIL, times m plus 2, which is more multiplication that we might not want to do. This is our final answer. We do not have to go through all of this foiling over here. Okay, that's what really happened. Okay, this looks a little bit cumbersome at first, but once you get the knack of it, it kind of goes quickly because the Pascal's triangles row always goes there, the first term goes there, and the second term. And if you can remember that you multiply within these terms, multiply within each term. Multiply, don't add them. Multiply within each term. All right, so that's your example. And now the last page of the notes, all we're going to do is go through a few other examples. Now this one is different because it's a subtraction binomial. So there are a couple different ways you can do subtraction binomials. I'll show you the way that I like. First of all, this 4 means we're going to take the fourth row of Pascal's triangle. So what you're going to have to do is you're going to have to know how to build a Pascal's triangle from scratch. And remember, to build it from scratch, you start with 1, 1, 1, a little triangle of ones. And then you go down to the next row and you put the outside ones down and you add those two terms together. Then you put the outside ones, add, and now we have to go down to the fourth row, which is 1, 4, 6, 4, 1. So we're going to take the Pascal's triangle row and write 1, 4, 6, 4, 1. Then we're going to take the A and mark the A next to everything. And the A gets raised to the fourth power, then the third power, then the second power, then the first power, and then the 0 power. And then the next thing you can do is you can either take a -3 and put it in parentheses and raise it up to a power, or what I'd like to do is I like to just take this as a +3, and I'll show you how we're going to account for this minus in here. So we're going to take the 3, I'm going to put them in parentheses just to show that it's multiplication, and the 3 gets raised to the 0, 1, 2, 3, and 4. Remember, you always end up with what you have here, and you always begin this first term with a 4. And because we have a subtraction, this first term is always positive no matter what, and then it alternates plus, minus, plus, minus, plus. So the alternating signs happen when you have a subtraction binomial. If this was addition, these would all be pluses like the last example. So now our job is to simplify each term. 1 times a to the 4th times 1 is a to the 4th. 4 times a cubed times 3, 4 times 3 is 12. 12 times a cubed. But this is going to be a negative term because of that minus. Now we have 6 times a squared times 9. Well, 6 times 9 is 54. I'm going to put a plus sign because this is positive. 6 times 9 is 54, a squared. The next term we have is going to be negative. So 4 times 3 cubed is 27, and I'd like to see what 27 times 4 is. And that is equal to 108. So we have 108 times a to the first, and it's negative. And then our last term is positive. 1 times 1 times 3 to the 4th, and 3 to the 4th is 81. And there's no a's next to it because a to the first is just a 1. So we can now write this. This is a vertical representation. Now we can just write it horizontally. A to the 4th minus 12a cubed plus 54a squared minus 108a plus 81. And that is our answer. And that is much faster than multiplying a minus 3 times a minus 3 times a minus 3 times a minus 3. That's long and tedious. This is a shortcut. Okay, the next thing we're going to do, this one is even different than the other ones because your first term has a 2x in it, and your second term has a 3y in it. So we're going to have to be real careful when we raise them to the power. So we have to go to the fifth row of Pascal's triangle. So the fifth row, if we can build it ourselves, 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. The next thing we're going to do is put the first term next to it, but I'm going to put parentheses around it because it has both a 2 and an x in it. So 2x in parentheses. This is really important when you have a term that's got two parts to it. Now we're going to raise this to the 5, 4, 3, 2, 1. You always end up with a 0. And then we have the 3y. We're going to put that right next to it in parentheses, 3y, because these are all multiplied. Multiply within each term. 3y, 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 and 3y. And what do you raise it to? You start with a 0 on the second term, and you go up to 2, 3, 4, and 5. Now, because this is a plus, all of these terms are going to be positive terms. All of them. You only alternate when you have a minus. And now our big job is to simplify each term. So this is kind of tricky when you have all of this stuff going on, but we have 1 times 2 to the 5th x to the 5th. Well, 2 to the 5th, that's 32. So this becomes 32x to the 5th, and then 3y to the 0 is just 1. So that's the first term. The next term we have is 5 times 2 to the 4th times 3 to the 1st. So let's do this. 5 times 2 to the 4th times 3 to the 1st, because those are the numeric ones. And so we have 240 coming up as our numbers. 5, 2 to the 4th, 3 to the 1st. That is a 240, and we have an x to the 4th, and we have a y to the 1st. The next term is 10 times 2 to the 3rd times 3 to the 2nd. So 10 times 2 to the 3rd times 3 squared will give you 720. So that's the numerical part, 720. And now we have an x to the 3rd and a y to the 2nd. Now we're going on to the next term. 10 times 2 to the 2nd, which is 4, times 3 to the 3rd, which is 27. And we have 1080 is our next coefficient. And then x squared y to the 3rd are the variables. The next thing we have is 5 times 2, which is 10, times 3 to the 4th. So 10 times 3 to the 4th is 810. X to the 1st, y to the 4th. And then the last one, 1 times 1 times 3 to the 5th. 3 to the 5th is 243. And then x to the 0 is just 1, so we have y to the 5th is our last term. And now this is a vertical representation. Now we'll just turn it around and write it horizontally. 32x to the 5th plus 240x to the 4th y plus 720x cubed y squared plus 1080 x squared y, whoops, this should be y cubed, I made a mistake there, y cubed plus 810x y to the 4th plus 243 y to the 5th, and there is our answer. And that's a lot faster than multiplying 2x plus 3y by itself 5 times. And then just a couple of quick things. Sometimes you're only asked for one term, and you can expand the entire thing like we did above, or you can just stop where they want the particular term. Like in this example, they say the third term. Well, each one of these are terms. This one is the first term. this guy over here, he's the second term. And this one is the third term. Fourth term, fifth term, sixth term. So each one of these parts is called a term. In this problem, they want the third term of this expansion. So we're going to go to row 5 of Pascal's triangle, which we just did above. It's 1, 5, 10, 10, 5, 1. But they only want the third term. This will be the first, this will be the second, this will be the third term. This is the one we want right here. So we don't have to actually expand it all the way down. So now we're going to take 3x and put it next to these guys. But I can stop right there because I don't care about the rest of these. So we're going to raise this to the fifth, to the fourth, and to the third. And then we're going to take 2, and we're going to raise it to the 0, to the first, and to the second power. And the only one that we have to simplify is this because they only want the third term. So the third term is 10 times 3 cubed times 2 squared. 10 times 3 cubed times 2 squared, which is 4, is 1080. So we have 1080 x to the third. That is the third term only. And now they want the middle term of the next one. So the 6th row of Pascal's triangle, we haven't done that one yet. 1, 6, 15, 20. 15, 6, 1. Let's see if I can remember that. 1, 6, 15, 20. 1, 6, 15, 20. 15, 6, 1. So the middle term is this one right here, middle. First, second, third, it's really the fourth term. So we're going to take 2m and we're going to stop right there. We don't care about anything else. We're going to raise it to the 6th, to the 5th, to the 4th, and to the 3rd. And now we're going to take the 5 and we're going to raise that to the 0, 1, 2, to the 3rd power. And now we have to pay attention because this is a subtraction binomial. So this one is plus, minus, plus. Oh, this middle term is negative. So we have to make sure we write the negative out in front. It's a negative term. We'll write that negative. Exclamation point. So we have 20 times 2 cubed times 5 cubed is our numeric coefficient. 20 times 2 cubed, 2 cubed times 5 cubed. So there's our numeric value. That's 20,000. Negative 20,000 m to the 3rd. So remember, sometimes if you have a term in expansion that has a minus in there, sometimes your terms will be positive. All the odd ones are going to be positive. All the even terms are going to be negative. And that's it. It's been a great year. See ya.